Hello, my name is Don White, founder of Agility Science, LLC. I'd like to thank you today for watching my webinar, Organizational Learning, Unlocking Innovative AI with Lean-agile Mindsets. Today we're going to talk about delayed versus regular feedback. And then we're going to apply that to artificial intelligence development. We'll talk about how quality is key and how machine learning operations, MLOPs, is a key to achieving that quality. We will then walk through how you can capture really important current state data and how you can continue a journey using this thing called improvement kata. Now, before we jump into delayed versus regular feedback, I want to share a coaching story that pulls this concept together very nicely. I coached this financial data visualization team. They developed SAP dashboards for business decision makers. They delivered their dashboard increments every 2 weeks in accordance with the Scrum framework. Unfortunately, they waited until the end of a quarter to get any kind of feedback from their end users, their financial analysts. When I learned that they waited until the end of the quarter to get that necessary and valuable feedback, I asked them to describe some of the feedback that they received from the financial analysts. And this is what I heard. The dashboard was not at all what the financial analysts were expecting. The dashboard was way too complicated, way too over-engineered, and hard for the financial analyst to even use it. And one of the team members explained how they worked on it for 3 months and the financial analysts are not even using it. The technical product owner conveyed how the dashboard just didn't tell the story that the financial analysts needed it to tell. And then he pulled me off to the side and whispered in my ear, hey, my boss and the business stakeholders are putting pressure on me to get these developers to deliver solutions that our financial analysts can actually use, not this hard to use junk. So I internalized all this feedback. And then I walked the team over to the whiteboard over in the area. And I drew this graph. This graph, it's called the delayed feedback graph. And then before I explained the graph, I said, hey, you know, all that feedback that you just described for me, that is exactly the kind of thing you can expect when you're working in a delayed feedback environment. And then I explained the graph. I said, this graph that I just drew is an extrapolation from the book called The Lean Startup by Eric Ries. And then I explained how Eric Ries discusses extensively in his book about how it's been proven over and over in the software industry and also in IT systems development that the longer you wait to receive feedback from your end users and external customers, risk, rework, and waste go up over time. And as you can see, it's actually a linear relationship, that red dotted line. And I looked in their faces and I could see they were wondering, well, that's cool. Well, what does that mean? And so then I said, Eric explains this. And when you hear his explanation, it's going to make a lot of sense. The bottom line is this: anything that you're developing, whether it's a brand new product or you're trying to enhance an existing product, many assumptions go into those development efforts. And the larger the effort, the more assumptions are in that particular software effort. And the more assumptions that are in something, the more likely one of your assumptions is actually wrong. And worse, What if one of those assumptions impacts other assumptions? Now you have this really cascading mess. And before I could go on any further, I got interrupted by the team. And they said, Don, that makes sense, but how is that going to help us? What can we do differently? How can we do some things better? Well, that's when I erased the red dotted line and I drew a new graph, the regular feedback graph. And I explained this is another graph that I extrapolated from that same book. And Eric explains a better way forward. Look at your backlog of stuff and try to identify the things in your backlog that have really important assumptions that you need to get validated early. And especially assumptions that impact other assumptions. And deliver that in a small increment to your end users and your customers, and have your business stakeholders there and the leaders of the team there as well, and demonstrate and discuss what it is that you developed. And the reason why you want to have this demonstration, everybody present, is it enables the people who are actually developing the solutions to get direct feedback from the folks who are actually going to use it. And by getting that direct feedback, the folks who are actually doing the work, developing those things, get a better understanding of why they need things in certain ways and what is the whole reason why they need this whole big solution in the first place. Because the better they understand the wants, needs, and desires of the people who are requesting things of them, the more likely the teams, the developers, are going to be able to uncover some innovative solutions for those folks. But here's the other thing that's really important. When the team is able to ask qualifying question of the business stakeholders and the customers or end users, the customers, end users, and business stakeholders learn the types of information that the teams are going to need in order to be able to deliver them value. So there's learning going on. You got the business stakeholders, you got the customers, end users, they're all learning. Well, then if you got leaders there as well, they're observing all this interaction and they're learning as well. Bottom line is all that learning that's going on is organizational learning. That organizational learning is then applied to the next time the team delivers an increment, which is represented by that orange line. Well, that orange line resets back on the horizontal axis because feedback was received. And learning, since learning was applied to that increment, that organizational learning was applied, you can notice how the slope of the line went down. And that's because risk, rework, and waste went down because they were able to apply that learning, that organizational learning. Now let's say we broke this down into even smaller increments. Look what happens. The bottom line is the more you can apply organizational learning to incremental delivery, you can expect risk, rework, and waste to go down over time. And the other thing that's really important to point out is when you deliver incrementally, there's value being delivered each increment. So the end users and the customers are getting incremental value over time. Whereas if you go all the way back to the delayed feedback, there's no value until they see it at the very end. So you go back here, incremental, you get incremental value as well. So that's really important to point out as well. Now let's go ahead and apply this to artificial intelligence and machine learning development. Now, as you can see in this particular slide, you have a non-machine learning development and that team, and then you got a machine learning development team. And as you can see with the machine learning development team, there's some additional roles. And then you add an additional discipline of mathematics, right? And by tapping into all these perspectives, that's how you get that innovative solutions to emerge. And that's really exciting. And however, doing so adds complexity, which also elevates risk. Now that provides more reason for incremental artificial intelligence delivery. Now, with incremental delivery, that minimizes the risk of building the wrong model, optimizing the wrong metrics, overshooting the required achievement in any of the metrics. But in order to deliver incrementally, quality is absolutely key. It can quickly become exponentially harder to execute on the requirements as your machine learning solutions evolve if standards, processes, and internal quality are not a core part of the effort. And machine learning solutions built with low standards will also be solutions where it is very hard to resume work once you pause to get that really real world feedback. Now, this is where the machine learning operations comes in and adds a ton of value. Machine learning operations, or MLOPs, asks a very important question. What does it take to deliver high quality increments once per day per developer? Now, talk about incremental delivery. That's pretty rapid, right? Now, this comes from Google. Machine learning operations is an engineering culture. Culture is a really important thing to point out, because it's something that's more than just something that the development teams do. It's something the whole organization is a part of. That's that organizational learning part that I'm talking about. And while this is a practice that aims at unifying machine learning system development and machine learning system operations, when you're practicing MLOPs, it means that you advocate for automation and monitoring at all steps of machine learning system construction. Now, that includes integration, testing, releasing, deployment, and infrastructure management. So what I would like to do now is walk you through the system and lean thinking part of this journey, because getting to MLOPs is definitely a journey. And it starts with gathering and visualizing data on how work flows through your value stream. You're really trying to get that current state data on where you're at right now. And this is actually a way to do more of that organizational learning. Now, before I begin diving into value stream mapping, I want to share a journey of a very courageous machine learning team. I had the privilege and honor to be their DevOps Dojo Sensei. And by the way, this team became champions in their company for DevOps coaching. Now, this team, they did not have ops roles on their team. They were just a team of machine learning engineers, not very cross-functional. Each team member worked separately on their own disparate machine learning solutions. And since they were not working together, opportunities to learn from one another were very limited. They waited until they had complete machine learning systems, sometimes months, before getting any feedback from the end users they were developing their solutions for. Now, during the first week I was there with them, this team, along with a bunch of other teams in the machine learning teams in the area, got pulled into a war room for multiple days. And that was because their machine learning platform went down. All machine learning solutions across multiple teams were dead for 3 days. Now, I shared this beginning of a journey to give you an idea of where your MLOPs journey can begin. You may be way further along in your journey, and that is awesome. But I just wanted to give you an idea, as you can start anywhere on your journey with MLOPs. Okay, now we can walk through a very valuable exercise that provided this team with very valuable current state data. Now, some of you may have already done this before. Now, that's okay. I do a very simplified version of this and will fast forward through the mechanics. Bear with me. I feel this quick walkthrough is a good application of system and lean thinking. Now, one of the really important goals of doing a value stream mapping exercise is to gain a collective understanding of the current state. So I encourage the team to invite anybody external to the team that they work with when they're developing their machine learning solutions. And when they do invite those folks, prepare them to commit to a whole day, because this is a very active participation type activity, and it's very eye-opening and gratifying. Now, you can do value stream mapping virtually, and there's a variety of different ways to do that. I'm going to walk you through how we did it in person. And what we did in person is we got a big room, a big enough room to accommodate everybody who was invited. And then once everyone was there, then we walked up to a whiteboard or an open wall in the room, so that where we could add sticky notes and that type of thing. And so I explained the whole purpose of doing a value stream mapping exercise, and that is to identify all the steps it takes to develop a machine learning solution, or in whatever software development effort is going on. You want to identify all the steps, and then you want to collect data on all those steps so that everybody's on the same page. That's what we're trying to do. And so then I start off the session by saying, hey, what is the first step for you to develop your machine learning solutions? And they all had to come to a consensus. There's a little bit of a debate and that type of a thing, but they said their very first step was to define their key performance indicators. And then I asked, okay, so then what's your next step? Well, they had another debate, and they came to a consensus that their next step was to collect data. Well, then I keep asking the folks at the session all the steps, and we captured all of these steps. Now, just simply capturing these steps and the order of the steps, it adds a ton of value. Everybody's on the same page there, but there's a lot more value we're going to get from this. We're going to capture some additional data. We're going to look at the first step. We're going to say, I asked the folks there to tell me how much time they actually spend with development on defining their KPIs. And they said 3 days. And then I asked, well, how much total time does it take to actually get those things defined? And they told me 21 days. Well, then the next question I ask is, well, what is your level of confidence that you captured the key performance indicators? In other words, do you have to redo them or anything like that? Give me a percentage of your confidence level. Well, they had a debate, and they concluded that it was 50% confidence level. Well, I asked those same questions for every one of the steps in the value stream, and that is what they came up with. And this is adding all this data on each of these steps is adding more collective understanding. That's that organizational learning that's happening within that room, right? So this is some powerful stuff, but it doesn't end there. We use this value stream map to identify bottlenecks in their value stream and quality issues. And a bottleneck is a step that's taken a lot of time in holding up work getting through the value stream. A quality issue is when you have a low percentage of confidence and that type of thing. But in addition to looking at the data on the value stream map, you also want to remind them to think about, when they're developing their solutions, factor that into your analysis, because what I wanted to do is I wanted to challenge them to identify their number one bottleneck and their number one quality issue. And then I walked out of the room for 5 minutes, and I was expecting to come back and have them present me their number one bottleneck and their number one quality issue. And you can pause the video right now so you can look at that. And now I'm going to go ahead and move on to what they concluded. Now, as you can see with the red text on the cards here, that define key performance indicator was the bottleneck that they identified. And as you can see, that's the step that takes by far the longest. And it's the very first step in their value stream. But the quality issue that was important to them was selecting a model. And I wanted to understand why it took so long to define their key performance indicators. So I asked, and they explained that when their machine learning solutions that they develop contact multiple entities, they have to work with multiple entities to define these KPIs. And that's why it takes 21 days. And then the other thing is why they select a model as their quality issues, because they explain how multiple times it's all too often they'll be developing a machine learning solution and discover that they selected the wrong model, and then they have to start from scratch, which also entails redefining key performance indicators. So you can understand why they picked that as a quality issue. But the thing is they were conflicted on whether to attack the select a model quality issue or the bottleneck. And that's when I said to them, hey, you guys, you can actually do them both at the same time. And then that's when they all looked at me really funny, like, well, how are we going to do that? And then what I did is I walked everyone there in the room through the delayed feedback versus the regular feedback graphs that I've already walked through in this particular talk. And as I was walking through that with them, I started to see light bulbs click in their faces. They were excited because now I could see that they wanted to use that for moving forward. But they still were unclear on what they could do to help themselves with that model quality issue. And so then I walked them through this thing. It's called set-based design. And this is a practice that keeps requirements and design options, which you can also say model options, flexible as long as possible during the development process. Instead of choosing a single point solution up front or a single model up front, set-based design identifies multiple solutions simultaneously or multiple models simultaneously and explores them, eliminating the poorer choices over time. And they were still wondering, well, what does that mean for us? And I said, well, what do you think? I asked them what they were thinking about the incremental approach to delivering their solutions. And there's that makes sense. They really like that idea. I said, well, if you use incremental delivery, you can have multiple models working at the same time in your sprints. And you can have some people working on one model, a couple others working on model B, and another set of people working on model C. So you can have 3 models of experiments going on in your sprints. And then after your sprints, you can look at the outcomes of those sprints and see what model is producing the better outcomes. And you can do multiple sprints to determine which model you want to coalesce on, and it'll be easier for you to switch in that type of thing. Well, so what we did next is we captured their experiments and what's called their improvement kata board. And so this is we drew this up on their whiteboard, and this is a way to track their experiments that they're running in their sprints. Because the first experiment they wanted to do is, instead of actually waiting until they had their complete machine learning solution developed, they wanted to deliver in 1-week sprints and then demonstrate what they've developed to the end users, their business stakeholders, and have their leaders there, just like what I was talking about. And then I said, okay, well, if you want to do that, what are you hoping to achieve by doing that experiment? And they said, well, we're hoping it's going to be easier for us to define our KPIs. And I says, well, we'll capture that result after you do your experiment. And they said the other experiment we want to do is we want to apply that set-based design, and we're hoping that that's going to make model choices. It's going to help us make better model choices. So they ran these experiments through multiple sprints, and this is the results. So for the first experiment, for what they learned by doing 1 week sprints is they were getting better key performance indicators because they were able to apply that organizational learning. And then with that set-based design, they loved the fact that they did not have to redo work to switch to models because there was a model already in flight that they could quickly switch to. But the thing that was better about that is it made sense. They had confidence to switch to the other model because they could see actual outcomes. They could see how this one particular model was the best one to switch to. So they actually felt confident about switching to this model. But the thing that was even more gratifying to them is how they learned a ton from each other, and they wanted to continue that throughout their journey. Well, these were just 2 of the experiments that this team did. They did a ton more of experiments, and they would evaluate their experiments after each sprint, so whether they got the outcomes they were hoping to achieve. If they didn't get the outcomes they're hoping to achieve, they asked, well, should we just continue this experiment longer to get more data? And at some point they would determine whether they got enough data and either abandon what they were doing or continue what they were doing. Bottom line is they use this improvement kata to continue their journey and optimize their value stream and bring down their lead time and their cycle time and that type of thing. Well, I hope you can use some of these ideas on your journey toward MLOPs. To summarize how you can lean out waste in your value stream system, when you do your value stream mapping exercise, include all of the people whom you work with external to your team. And then once you have your value stream mapped out, identify the bottlenecks and quality issues. And then use that improvement kata board to track all of your experiments that you are conducting to remove the bottlenecks and quality issues. It's really important to do this on a cadence so that you can continue optimizing your value stream. All right, well, that concludes this talk on organizational learning, unlocking innovative AI with Lean-agile Mindsets. I do welcome your feedback, especially on topics you would like me to cover in future webinars. Thank you and have a great rest of your day.